Assalamualaikum warahmatullahi wabarakatuh, and hi, I am Amira Fatonah binti Kamsani from Section 2 BMFG Group 2. I will be in charge for task number 1. How many printed circuit boards are processed after 8 hours? Document your approach in short words. I will present my words in document. So that's all. Thank you.
Assalamualaikum warahmatullahi taala wabarakatuh. My name is Nik Nur Fatima binti Muhammad. I was from Section 3, Group 2, and I was in charge for Task 2, which is present the model and explain the results with a video presentation. So without further ado, let's start build the model. Resume to the question. Here is the models that we need to build. There's about 10 conveyors, 1 source, 1 drain, 9 buffers, and 9 stations that is renamed as DIP 1 until 4, RAD 1, 2, VCD 1 and 2, PIN. And there is 3 files here that is renamed as DC type, process plan, and analysis. And 1 method which called NSIM. Here are some information that instructed us to build the model. First of all, the uniform distribution for the source is between 30 seconds to 1 minute and 30 seconds. There is also 4 types of containers that will rename as DC type 1 until type 4. The length of the container is about 600 millimeters, which is equal to 0.6 meters, and then it will be sent to the drain. And here, the tables here, it shows the working time for RAD, VCD, DIP, and PIN. So here shows the information how we need to construct the directions of from the source to the drain of the container. Without further ado, let's build it. Actually, we already built the simulation. This is the result as the same as the question here. So I'm going to explain more on details of each unit that is shown here. So I'll start with the source, what we edit in each of the units. For as the source, the attributes, the interval times that is stated like in the question here is between 30 seconds and 1 minute 30 seconds. So we put in here an interval is uniform instead of constant. And then the table is DC type, which is the containers type. And next, I will spend more on the conveyors here. We have 10 conveyors and 9 sensors in each conveyors. So the length of the sensor is 1.5. And the control models, as you can see in the screen, is models flexible production line F1, sensor F1, which is different from each conveyor. As for conveyor F1, what we put inside is the length of the conveyor is 3 meters, same as all the conveyors. But what we did is we just add coding in the conveyors. We name it as sensor F1 is for conveyor 1 and so on. As for F2, sensor F2 and until F9. As for sensor F1, the data type is method. Then I'm going to open this, and this is the coding that we add into the conveyor. All of the conveyors have the same coding, but we only change on the containers and also the buffer's name. I will show you for F2. Here, buffer 2. And I'm going to show for F3. type 4 buffer 3. And then I'm going to explain on the buffer. So here we have 9 buffer. I'm going to open the one. Each capacity of buffer is 2. All of the buffers have 2 capacity actually. And then the dwell time is 1 minute. That's all for buffer. Nothing much. And then for the station, I'm going to start with the IP1. The IP1 and the until the IP4 have same processing time, which is 2 minutes. But we only edit it on the exit. We also edit it on the exit. We set it as self on exit F1, so that when the container came from source and go to F1 and they find out that session 1 has 3, means there's nothing works to do, they will go inside here, go to buffer 1 and then go to the here the IP1, and then when the processing time for this part ends, the container will go straight away to F2 and then goes to drain. Next is all of the stations are the same, but the difference is only where the exit control. I will show you for the IP3. Here the processing time also 2 minutes. As for control, self on exit on F3, which is here. Now for RAD, VCD and PIN, we also edit on the exit, on the controls exit accordingly, but then we only change on the processing time. As for RAD, the processing time is 3 minutes. For VCD, it's 2 minutes, and for PIN, it's 1 minute, according to the questions here instructed to us. And then I'm going to explain more on analysis. Here are the results of the analysis that already calculated automatically from the program. I will show you the program. Here are the programs that we already downloaded from Ulearn and we just import it. How to import? Just click import here and then you click the nsim, and then the result will be like this. Will be full like this. As for processing plan, also the same. Here's the example that we downloaded it from Ulearn. We just import it straight into the files, the table files. This one. Sorry, this one. Process plan. And then we just input it here. And as for TC type, we put it accordingly since container has 4. So how to build this thing is we click it here and then right click and click on the format, and then you can just change the data type according to what you want. And then for this one, you click on this column index and this will appear. And for this, you need to duplicate the container 4 times, and then you rename it like this. TC type 1, type 2, type 3, and type 4, accordingly to the instruction. And then from here, you drag it to here, and then put the frequency. That's all for TC type stables. And then connect all of the units accordingly, and let's start. Don't forget to set up the time for 8 hours so it will end accordingly to the time here. And so we got the answer, throughput, the total for each container. As for type 1, it is 61. For type 2 is 73. For type 3 and 4 is 77, which the total of them are 288. And the production, as you can see here, which type 1 is more productive than others. As transport, type 4 has the most transportation than others container. And the value added, which is type 2 has the more value added than others. As the mean lifetime, the containers that takes the longest time to produce the input, the output is type 3, which is 1 hour and 4 minutes. And the lowest is type 2, which is 53 minutes. For now, that's all. Thank you.